Hi, my name is Jamero Blue. Today's date is September 25th, 2016. And today I'll be talking to you about bivariate analysis and contingency tables. What exactly does a bivariate analysis mean? A bivariate analysis is defined as one of the simplest forms of statistical analysis. It's used to find out if there's a relationship between two sets of values. For example, finding out the weights and heights of college students. The two categories used in this example would be one, the weights, and two, the heights. Another example of a bivariate analysis is finding out how the weather affects the cells depending on the temperature of each day. What is a contingency table? A contingency table is defined as a table used to classify observations according to two identifiable characteristics. Now, a lot of people might ask, why are contingency tables used? Contingency tables are used to analyze and record the relationship between two or more categorical variables. It is also the categorical equivalent of a scatter plot, which is used to analyze the relationship between two continuous variables. This is my real estate data provided in a workbook by my teacher. If you look closely at this data, you see that we have 8 different categories, which contain data about houses. 1, the price. 2, the number of bedrooms. 3, the size of the house. 4, if the house has pool. 5, the number of baths in the house. 6, the township. 7, the number of garages. And 8, the distance. I will use this data to give an example of a contingency table. This is my contingency table example. The categories I used in this example were the baths category and the pools category. If you look closely at this contingency table, you see that there are 10 houses with 0 pools and 1.5 baths. There were 42 houses with 0 pools and 2 baths. There were 7 houses with 0 pools and 2.5 baths. And then there were 8 houses with 0 pools and 3 baths. Adding all these up, you get a grand total of 67. There were also 6 houses with 1 pool and 1.5 baths. There were 23 houses with 1 pool and 2 baths. There were 8 houses with 1 pool and 2.5 baths. And lastly, there were 3 there were 3 houses with 1 pool and 3 baths, which gives us a total of 38. Adding the 67 and 38 together, you get a total of 105 houses. You get a total of 16 houses with 1.5 baths, a total of 65 houses with 2.5 baths, a total of 15 houses with 2.5 baths, and a total of 9 houses with 3 baths. The sources I used to create this presentation was statisticshowto.com and the Statistic Techniques in Business Economics textbook for the class, the 15th edition. Thank you for watching my video. Have a nice day.